All right, hi. We are on lesson 3.5a. We're talking about zeros today. Zeros are the same thing as an x-intercept. Where does my polynomial function, my graph, cross or touch the x-axis? That's a zero. So the point at which a function intersects is the x-axis. Okay. A polynomial function of a degree n. So if it's like to the fourth degree, then it can have at most 4 zeros. It could also have 3. The exponent tells us at most how many zeros there would be. Okay. Could have less. Okay. This would be if it were like x to the fourth. It would have 4 zeros, or 3 or 2. Okay. An even degree polynomial has an even number of zeros. And an odd degree polynomial has an odd number of zeros. Okay. So on number 1, first let's talk about what's the leading coefficient and what's the degree. Remember this from days ago? Days ago, last week. Okay, somebody, what's my leading coefficient? Colin, what's my leading coefficient?
Isn't it 1?
It's 1, which means it's positive. My degree, Colin, is what? What degree is my whole equation to? Josefa?
3.
3, which is odd. Reminder, a positive odd function looks like this. Okay. Flashback from like a week or 2 ago, right? So here's what's happening. Number 1, you need to factor if you can. And number 2, you find the zeros. So I'm going to factor. Sorry, I can't turn my, oh, I guess I can turn this. Sometimes the cord is sensitive, and if I move it, then the whole document camera shuts down. So, okay, x cubed plus x squared minus 2x. Let's factor that. It has an x with it. So I'm going to factor out my GCF of x. I think that'll, yeah, that's good. Factor out my GCF of x, and I get x squared plus x minus 2. So what? How do I factor that? 0 equals x and what? I need, thank you, Sky.
Is it x plus 2 and x minus 1?
Yep. That means, you guys, that those are my zeros. I have a 0 at x, 0, at -2, and at 1. So I'm going to mark those on my graph right now. 0, -2, and 1. Okay. I need to talk about this word multiplicity. Multiplicity is like, what are the exponents on my parentheses? They're all 1s, aren't they? To the power of 1. Remember that? So an odd multiplicity, like a 1 or a cubed, crosses the line, whereas an even multiplicity, if I had a squared on my parentheses, that would bounce. Okay. Now, I know that it looks like this. I know that they're all to the power of 1, multiplicity of 1, so they're all going to cross. I don't know where my turning point is. Remember, the only way we can find turning point is if we actually use Desmos. So I don't know what my turning point is. So here's what it looks like. Even though it's not perfect at all, this is the general shape of it. And I can even do that in a color. All right. That was easy because that polynomial was factorable. That was nice because the polynomial is factorable. Guess what on number 2? It's not factorable. I can't just do parentheses and figure this out. I also don't want to sit and do a ton of synthetic division. So let's look at this from yesterday. Remember yesterday how I was able to just plug in numbers that I thought might be factor? And if I got a 0 as my remainder, then I knew it was a factor. So when you get a 0 as a remainder, you know it's a factor. I need to test out some numbers that I think might be factors. I got to tell you, you got to look at this last number here, this 3. And you can only pick numbers that possibly might go into 3. There's a lot of numbers that go into 3, some fractions even. But my point is, let's pick the obvious ones, like try. So I'm going to try factors of 3. So like 0 or 1 or -1 or 3. Those numbers go into 3, don't they? So I'm going to try those 4 numbers. And I'm going to try them by plugging them in. I'm not going to do synthetic division. I could absolutely do synthetic division for every single one of these and try it. Remember, I want a 0 remainder. Okay, I want a 0 remainder. That's what I want. So what this means is, and I did these on a separate little piece of paper for you guys, just to make your life easier. I'm going to try f of 0. I'm going to try, because you always have to see if 0 is a factor. I'm going to try f of 3. I want to see if 3 goes into 3. Is 3 a factor? I want to try 1. And I want to try -1. Now, I picked these numbers just out of my brain. I really did. You wouldn't be able to know what the factors are any other way except for what I'm doing right here. I looked and I said, hey, the last term is 3. I know that I need to pick numbers that go into 3. So here is when I plug in 0. And I already did these for you last period to make your life easier. -0 to the 4th plus 4 times 0 cubed minus 2 times 0 squared minus 4 times 0 plus 3. Well, it turns out, you guys, when you work it all out, you just get a 3. So that doesn't work. It's not a remainder of 0, and I want a remainder of 0. Okay, so moving that aside. Let's try 3. Here's 3. -81 plus 108 minus 18 minus 12 plus 3. Great news. It equals 0. So that means that 0 is not a factor. 3 is a factor. You know something about 0 though? This is an ordered pair. That's my y-intercept. So that's what happens when I try 3 to see if 3 is a factor. I got a remainder of 0. That's good. I want that. Let's try positive 1. Ready? Negative 1 to the 4th plus 4 times 1 cubed minus 2 times 1 squared minus 4 times 1 plus 3. Negative 1 plus 4 minus 2 minus 4, or wait, plus 3. Now your 1 plus 4 is 3. 3 minus 2 is 1. 1 minus 4 is negative 3. Negative 3 plus 3, 0. Yay! Okay. Oh, I should have written that down. Hold on. Negative 1 plus 4 minus 2 minus 4 plus 3 equals 0. So yes, 1 is a 0, an X-intercept. Now here's negative 1. Negative 1 plus negative 4 minus 2 plus 3 plus 4. So negative 1 is also a 0. Now, I found my 3 zeros. Something that I haven't done yet, which I need to do, is I need to talk about what's my leading coefficient and what's my degree. Leading coefficient, degree. My leading coefficient is negative. My degree is the 4th. So this is an even degree and it's negative. Do you remember the end behavior? Remember that? This. Okay. So here's what it looks like. Let's draw it. Okay. My zeros are at 1, negative 1, and 3. And this is the shape that my graph looks like. I don't know my turning points. I know a y-intercept, 0, 3. So now, this is generally the shape of my graph. It's going to come up and down. This is the hardest problem on the whole worksheet. It's the hardest problem because I literally had to figure out what my roots, my zeros were by guessing, by trying it, plugging them in. And that's hard. Okay, so let's go down to the next problem. The linear factors of a polynomial reveal its zeros. Yes, we know, because when we know the factors, we know the zeros. Linear factors can be found by writing the polynomial in factored form. Yeah, we also know that because we've been factoring polynomials many days now. So here we go. I need you on number 3. So please just factor. Here we go. There's a GCF. The GCF is X. And of course, when I write equals 0, you know that that means that you need to set them all equal to 0 and figure out what my zeros are. Can someone tell me the factor of this here? This is obviously X equals 0, but what's this?
Five and negative 3.
It's the other way around. X minus 5, but you're right. Hold on. The parentheses say this, and then X equals positive 5, X equals negative 3. So there they are. 1, 2, 3. Life is really good when you can factor a polynomial. Number 2 wasn't factorable. Life was hard. I actually had to go through and test out numbers that were factors of 3. Okay. Here we go. Yeah.
Are we gonna have a question like number 2 on our test?
No, I'm not going to ruin your life. I mean, I laughed, but I'm not really going to. I'm like, I wouldn't. That's not cool. I'm cool. And when you get a hard polynomial, you use Desmos. Let's be honest. When you're out in the real world and you decide when you're 36 years old, hey, I want to graph a polynomial today, you're going to get out a graphing calculator, right? And by the time you're 36, Desmos will be like, there'll be some new cool website. I don't know. Maybe you could invent it and become a billionaire. You should probably do that. Just go ahead and do that real quick. All right. So, multiplicity. We talked about it in the front side. Let's factor number 4. Here we go. X is a GCF. What is the rest? Oh, I went too fast. I'm sorry. Sorry, I can't do it that fast. Wow. Okay. Sorry. X squared minus 6x plus 9. Okay. Now, what are my 2 parentheses? Sorry, I was going a little bit too fast there. I gotta hustle. Guys, what is it? X squared minus 6x plus 9.
People have their answers.
I want the parentheses first.
X minus 3 and X minus 3.
Great. I think I should make my life easier and go X and then X minus 3 squared, because I really care about what's this exponent and what's this exponent for multiplicity purposes. I know that my zeros are 0 and 3. So I just want to remind you that the x equals 0, 1 has a multiplicity of 1. And that my x equals 3 has a multiplicity of 2 because it's squared. You know how the exponent tells you the multiplicity, right? The exponent tells you the multiplicity right here. 1 and 2. That tells me my multiplicity. So now number 5 is the exact same problem, but we actually get to graph it. We get to. All right, here we go. The x equals 0 has a multiplicity of 1. That's odd, right? My x equals 3 has a multiplicity of 2, and that's even. The leading coefficient and the degree always need to be talked about. My leading coefficient is odd. My degree, oh, it's odd and positive. Odd. Ay, ay, ay. Leading coefficient is positive. My degree is odd. That looks like this, guys. Odd, positive. Looks like that. Remember? If the multiplicity is odd, the graph crosses. If the multiplicity is even, then the graph bounces. Let's draw it. My zeros are at 0 and positive 3. Okay, I don't know where my turning point is. I don't, so let's do purple. Like that. Doesn't it bounce at 3? Because it's even, remember? So that's why it bounced at 3, it didn't cross over. Okay, going to number 6. Number 6, we have filled out this chart before, remember? The 0 is at -7, -1/2, and x equals 4. The multiplicity is right here. When my 0 is -7, my multiplicity was squared 2, and the effect is that it bounces. When my 0 is -1/2, my multiplicity was at 1 because it was, see, exponent of 1. 2x plus 1 to the power of 1. That crosses. When my 0 is at 4, I have a multiplicity of cubed 3. That's odd. It crosses. I lose track of time, you guys. So this is not anything new. You're just saying, you're looking at the parentheses, you're looking at the exponent, and you're saying whether it crosses or bounces based on up here, odd or even. Number 8. A polynomial function has a 0 at -6. Okay, if my 0 is -6, that means the parentheses was x plus 6. If my 0 is at 2, oh, and it has a multiplicity of 2, sorry. If I also have a 0 at 2, that means my parenthesis was x minus 2 and a multiplicity of 1. I'm going to highlight those again because that's what we've been doing this whole time. Write a polynomial function in standard form. You need to do this. X plus 6, x plus 6, x minus 2. And you need to multiply it all out. So I will do that. X plus 6 is a perfect square trinomial. X squared plus 12x plus 36. Right? So I'm just like multiplying it out. And I'm getting fully done form x to the third plus 10x squared plus 12x minus 72. Okay. All right, what questions do you have? No, nothing? Okay.